Good evening. Thank you very much for coming again. About a year later, I think the last presentation was on Spark 2.x and Hadoop 3.0. Today we have got a very interesting, and it is a little bit code-oriented rather than slide-oriented talk. So please bear with me. I will try to complete it maybe in 30 minutes, the slides. And then we have to really see how things are working. That's where the real fun will come. And once you understand what this object store is all about and how it can seamlessly interoperate with all the technologies that you have learned so far, preferably in the big data world, you will be able to do some more business value to what you're doing, increasing the ROI, and maybe making your applications more productive. With that, let me start with a very, very fundamental concept from the lowest level. We will try to go to how much higher as possible. Interesting branch of mathematics, calculus, right? And first order logic or predicate logic. The theorems that are defined as the basics for computer science. And in predicate logic, this is how you will write predicates. Harry married Sally 12th December 1995, married. Is mother of, so Sally is the mother of Peter. Harry is the father of Peter. The gentleman E.F. Codd, around in the 60s and 70s, while dealing with the data, understood the value of this predicate logic. And he saw a great relation that he can incorporate into the way in which the data is represented. And he brought in the great relational model with 12 famous rules, which we call today as E.F. Codd rules. Any database, relational, not hierarchical or network, if you look, we say that it should satisfy most of these 12 Codd rules. And E.F. Codd created or suggested the term relation, which we all fondly call today as table. And in a relation, he brought in the concept of a tuple, which we call normally in our daily lives as rows, and the columns, he introduced the term attribute. So the best way to represent relational algebra or relational database management systems is to conceptualize the relations in terms of tuples and attributes. And once you represent in this way, you will be asking questions to that relation. There exists one or more X such that the marriage happened in 1995, for example. That's where your where clause came in and your select clauses came in, and you created the structured query language, which we call as SQL. So this fictitious company, which I am going to talk about a lot, has got two models of data contributed by two great data guys, Inman and Kimball. Inman mentioned that anything should be in terms of relations, back as normal form, normalized form, etc. And then from there you should create data marts, and from there you should be creating your cubes. And don't go to the rollup, molabs of the world, but just consider that there are some cubes, and you will be connecting your business objects or your Cognos or your Tableau from this particular layer to these cubes. This is called the semantic layer. The semantic layer is giving you the information into a subject-oriented, integrated, time-variant fashion, and you get all your data. The other guy, Kimball, he created a completely different approach to the way in which data is represented. Everything should be star model, fact dimensional model. And from the fact dimensional model, if you want, you can create a cube, and from there you can browse it. What's the difference, and what did this solve better than that? Of course, the query speed. When you are having a normalized form, you will have to have multiple joins, your inner, outer, left, etc. But when you are having a fact dimensional model, by product, by time, by people, you can just query that particular fact model and you can get the result. So, in this company, there is a data model already existing. And this data model has got a product, payer, fact table is there. These are all the dimensions. If you extend this, you may get a snowflake model as well. This is a pure star model. And in this star model, the fact table is there so that I can ask a question by patient, by product, by payer, by period, what is this particular value. Your fact table will be corresponding to each and every selection. There will be one value in your fact tables. Finally, you can reach to the fact table by looking at and all the reporting tools which are there, prominent ones, will automatically identify these facts and dimensions when you are importing it into that particular reporting tool. Well, the company was going on very nicely because of this particular table that is existing, which is serving all the applications, all their business needs. Suddenly, they started getting an idea. The idea is this: I want to improve the ROI of the company by bringing in something like this. I want the patient to give the feedback. The patient can give the feedback through YouTube, through Facebook, through WhatsApp, or whatever it is. I want to create all those things and analyze whether the patients are happy with a product or a payer, and then I want to create a feedback system and make sure that everything is going on very well. And they hired a new CTO, he or she. That CTO's task is to improve the ROI and improve the business by analyzing this particular data. Now there is a big problem. The CTO has got 2-3 options. The first option is change everything. And if he or she wants to change everything, that's a formidable task. Why? Because the people who created this particular model retired. And if suppose you want to create a YouTube and Facebook into this particular data model, how can I do that, first of all? So he thought the second option, okay, we'll keep all these things, but can we add additional tables? Again, your reporting systems, your cubes, your star model, everything will need to be recreated. Why? Because everything is tightly coupled. The CTO got into very big confusion and he started roaming around. Of course, the place, let's consider that it is Silicon Valley. Wherever he goes, the restaurants he or she goes, the restaurants, the meetings, library, everywhere, the people are sitting with the t-shirt of the elephant. Everybody is talking about only one thing. Everybody has got tattoos on their hand. Elephant, elephant, elephant. Everywhere it is that elephant that is running the show. All the people are talking about, MapReduce, this, that, and everything. And he got completely confused. What should I do? The next day when he is going for walking, there are people who are walking with 2 dogs, One German Shepherd known as Hadoop, the cat is known as Hive, and the other dog is known as Spark. What is this? Why so much attention and so much prevalence of this particular elephant-based technology everywhere? The CTO, he or she thought that divine intervention. Yeah. Answer is this. Everybody is talking about this. We will go with big data technologies. And we are going to solve everything. So, new digitalization initiatives are going to be started by this particular CTO by bringing in Hadoop into the enterprise. All the data started coming in from the Facebook, YouTube and everywhere. It has distributed onto so many servers. They started looking at the data. They are trying to create some analytics out of the data. And he read so many articles and he understood that he should call this particular architecture data lakes. I don't know why they are not calling data oceans or data rivers, but data lakes. Let's also adopt that word, data lake. So data lakes is the solution. Why? Because data lake will contain everything. Unstructured, structured, semi-structured, everything. And then from there we are going to create our data transformations and we are going to create the results. He started telling our company is going to become like Google because Clouder and Hortonworks, oh sorry, I should not tell Clouder and Hortonworks, both of them got married last week. Cloudenworks. So Cloudenworks, they came in and they created so many tools on the top of it. Well, the initial problem was this. There was a zip file and that zip file was sent from a third-party vendor because rather than managing the social analytics by themselves, what they did is that they contracted a third-party vendor. The third-party vendor will zip all the data, the Facebook, the Twitter, all the feeds of this particular patient's feedback and everything, and then will be sending it, and it will consist of so many files, PDF files, JPEG files, so on and so forth. File size is 8 GB. Hadoop supports 128 MB blocks. 8 GB divided by 128 MB, about 63 blocks, 3 times duplication. The total size, along with some additional metadata, 26 GB. 3 times the data is copied. And they started executing the application. Here comes the fun. And we will start with a small quiz if you are a Spark programmer. This is what the persons in that organization has written. They used a filter function and got that zip file. And they created a sequence variable called allZip. And then they executed a for each function for every zip file, because if the directory contains 10 zip files, it is going to iterate through all that zip files and it is taking each zip file. And in Hadoop there is a beautiful function, new API Hadoop file, which will read this kind of binary data. So we are using the Spark context new API Hadoop file, and then I am going to read that zip file. And for debugging purpose, the team has added a print line statement. Print the number of partitions. Can you guess what's the answer of this number of partitions? Remember, there were 63 blocks. You will expect that it is 63 because 128 MB blocks are being read. So each block represents each RDD. So it should be 123. Unfortunately, the answer is 1. Soon the team realized that there is something wrong going on there, and they went to the source code of Apache Spark, and there is the Hadoop RDD.scala. You can click on that link. And they saw that this Spark is tightly coupled with Hadoop. Spark, when reading the files, uses Hadoop internally. Spark leverages the Hadoop configuration. Even though Spark can work without Hadoop, Spark leverages the Hadoop configuration completely. And then they went into the details of this and they got this particular deck. What does that mean? Oh, Hadoop, yes, it is good for unstructured data, but you know, all the files in the world are not splittable. You will use Hadoop and maximize the possibility of Hadoop if Hadoop can split the files into 128 MB blocks. That's where parallelism is coming in. That's where distributed technology is going to come in. That's where your MapReduce will get executed on the parallel nodes. But if the file is not splittable at all, zip file cannot be splitted. Only files which are splittable here is bzip2 and LSO it should be indexed. Otherwise, all these files are not splittable. So what do you understand if the files are not splittable? If the files are not splittable, look at the Spark documentation. Spark uses 128 MB default by the HDFS. But if partitions are 1 or partition is equal to 1, if the file is not splittable, then Spark is going to take only 1 and it is going to be executed on 1 node. In the similar way, when you are reading the data from Hadoop, Hadoop is going to execute it on 1 node. Where is the data locality? Where is the power of Hadoop? That means certain class of problems has to be completely eliminated from Hadoop. The files which are not splittable will lose data locality. And in the large enterprises, all kinds of files are coming as PDFs, JPEGs, etc., which are all not splittable. If they are not at all splittable, then how come this big data and why they are all having tattoos and discussions? Subsequent months, the result of Cloud Works. We copied data from Netissa to Hive. Don't ask why. We copied big data. We created reports from Tableau with Hive ODBC. Oh, fantastic. Why? Was it not working against the old Netissa? Tableau superbly performs. And when you are using the Hive ODBC, you are not skipping the MapReduce. Still the MapReduce is getting executed. We have Hortonworks, but Impala is not supported by that. Impala is supported by Cloudera, another problem. This is before the marriage. MapReduce is slow. All data is at one place, so on and so forth. You can go and see all these reasons. The CTO, not only confused, but sad as well. All this great elephant world has told me that everything is going on well and everybody is talking about this Hadoop, but it is bringing all these problems. And look at this particular thing, cost of maintenance. 3 copies is too much. Rebalancing took entire week. That is the biggest problem in the Hadoop ecosystem. When you are having the name node, when you are having the data node, when you distribute the data, name node creates the journals or the FS image of how the data is getting distributed, which means that if you want to port that Hadoop file system to another place or another application, impossible. And as and when you are adding the nodes, it's not elastic, you have to do the rebalancing, which takes hours and hours of work. But what is needed for making the company famous? Again, CTO started roaming around what I am lacking. I need AI, artificial intelligence. How can I survive without that? That's the buzzword in the industry now. And it is not a typo. AI is different from AI. Oh, AI is different from AI. Then what is that AI and what is this AI? A one-page primer on AI. Autonomous systems which replaces, underline the word replaces. Human cognitive thought process is called artificial intelligence. So what is meant by cognitive? Cognitive is relating to cognition. And what is cognition? The mental action or process of acquiring the knowledge. So the mental action or the process of acquiring the knowledge, if a machine can replace it, that's called artificial intelligence. Example of artificial intelligence? If suppose a car can go without a driver completely, it is artificial intelligence. It replaced the driver. That's the important point. But there is another AI. Some people, as Dr. Michael Jordan in the last Spark Summit mentioned, it is also called as IA. What is that? Intelligent augmentation or augmented intelligence. And what is augmented intelligence? It will not replace the human being, but it will support the human being. Example, I am the driver sitting in the car, but car has got an AI-based collision detection system which will prevent me or help me to avoid collisions. It is supporting the driver. Driver is human. That is augmented intelligence. Mostly we are seeing augmented intelligence, and the people use vice versa, AI. But it is augmented intelligence until you completely replace it, which is maybe a decade away. We are close to that. Now, if AI or IA you want to implement, you need two things. What are they? That's the definition of machine learning. Machine learning or deep learning is a mean or the method to implement either AI or IA. And what's the difference between machine learning and deep learning? If suppose I am showing you the pictures of cats, dogs, and so on and so forth, if your system can identify a cat from a dog, that is machine learning. If I give you 1,000 cats, and if the system can identify which type of cat it is, that is deep learning. You are going inside. Both machine learning and deep learning are the means to do IA. And one beautiful definition I found out after reading all these things is, in the conventional world, you have an input, you have an algorithm, and you get an output. Example, 1, 2, and 3, three numbers. Your algorithm, multiply, the output 6. 1, 2, 3 multiplied by, you get 6. Multiply three numbers. Another shift to this particular thought. Let's reverse it. I am telling you 1, 2, and 3, and I am telling you the output is 6. Can you tell me the algorithm now? No, don't say multiply. What about 1 plus 2 plus 3? You are confused. Give an input, get the output, analyze both, find out what converted that input to an output. You got artificial intelligence, machine learning, all these things. And now, let me tell you one thing. Assume that we are going to write an exam. That exam is going to be 1 hour duration. In 1 hour I should complete that exam, otherwise I will fail. So when I write that particular exam, I have to complete it in 1 hour. But the preparation that I did to write that particular exam is more than 3 to 4 months. So to get a real-time output, you need a preparation. That preparation time is not real time. Please understand that very important fact in the world of big data. Everybody says real time. You log into Amazon, Amazon is telling you this users bought these items also. These items can be proposed to you. When you go to Netflix, yes, these people have watched these movies. That is like writing the exam. But to create that particular output, there is somebody who studied the things in the background, taking days, hours, months. So understand that fact that output may be needed instantly, but learning it may take days, hours, or months. What is the classical problem? The CTO wants to read the social security number by the system. And the social security number is coming in the PDF format by handwritten way. Handwritten documents, scanned images are coming to the system. And from that system, I want to find out what is this for. System is dumb. It cannot say it is 4. It will tell that it is 7. Now comes the magic. By applying a bias, weightage, etc., you are going to run billions of things into the system. From the billions of things that are going on internally, the system understands that, yes, S7 is 7, but the preparation time is huge. So, if the preparation time is huge, if the files, most of the types are not splittable, if real time is not what I want for my AI and my future, why should I use Hadoop as my file system? That's the fundamental of object store. The problem is with the file system. File systems are 4K in size of the blocks. Store system. So I took the reference of S3 for the purpose of comparison. As of yesterday, 23 USDT per TB per month, or 12.5 USD per TB for cold access. And you calculate everything for HDFS, $103 per month. 5 times cheaper. Add human cost, 10 times cheaper. S3 object store. From the Databricks blogs, based on our experience, S3's availability has been fantastic. And please search, I'm not putting that picture here. How many times you had to do the reformatting and rebalancing for Hadoop-based file system. Amazon offers this much durability, which is higher than an on-premise SLA. They have started thinking in that way, and that's what they are releasing as data plane services in 2019, where you can create the replication into other regions. Currently it is not there in Hadoop. Everything is in the same data center, 3 copies. That is about elasticity. Performance, I will discuss it in detail. Whenever you are creating a directory in Hadoop, you will write -mkdirs/a/b/c, which means that before putting a file, you must create directory. Whereas in object storage, preferably, I am taking an open source object storage called Minio, very simple to use. In Minio, you are not going to create /a/b/c one single command to put into your file. Why? Because it supports hierarchical naming conventions. Easier than Hadoop commands. Right, this is an interesting slide. Can anybody say me that when you are doing a save as text file in your Hadoop, you know that it will be writing the partitions, right? Suppose you are writing the word count. The results are going to go to 3 partitions if you are telling save as text file in your Spark program. If you put your number of partitions as 3, it is going to write 3 times. Assume that while the second partition is being written, something happened and that node goes down. What happened to your result? Have you ever encountered that particular problem? Save as text file, writes the partitions, and at that time there can be some problem while that partition is being written. How do they handle it? There is beautiful intelligence inside. They create a temporary file first, and once every temporary file is written successfully, then they dump into the actual partition, making sure that your results are not wrong. This is called Hadoop commit protocol. In object store, this facility is not available, which is a drawback. So when you are writing the data into object store, if the node or something is failing, then your data gets corrupted. How can we solve this particular problem? Look at another innovation from Spark, from Databricks. If you are writing a big range, 10 to the power of 6, and writing this particular data, there are two algorithms available on Hadoop. Spark uses Hadoop protocol, commit protocol. One algorithm is called commit V1 and another algorithm is called commit V2. We are going to apply that algorithms on this, and when you write the data, this is the performance. Look at the commit 2 and look at the time. This is very, very fast. That is a test Spark has done on the two algorithms. Now let us look what happens if an error is coming. For that, what we need to do, we need to create an error. So I am writing, throw a new runtime exception, oops, from Ravi. And I am running that. You execute this. Errors. No errors, almost. This many failures happen in commit 2. Spark told, we can't rely on this Hadoop commit 1 and commit 2 protocol, and they brought in what they call as DBIO, and please refer to this link. Databricks input and output protocol. In DBIO, it is much faster than Hadoop commit 1 and Hadoop commit 2, and also the task failure handled in commit 1 and commit 2, but the job failure was not handled as I showed you, but in DBIO transactional commits or protocol, it is handled excellent. So the summary is that whenever you are using S3 and you are writing to S3 or an object store, make sure that you are enabling the commit protocol to be equal to the DBIO. Otherwise, there can be failures. This is how an object store will look like. This is your block storage, and this is the object storage. An object storage has got data, metadata, attributes, and the ID. And please look at the beauty. This is the most important factor. The data and the metadata are different. They created an abstraction on the top of the file system so that LUNs and the managements are deviated away from this particular access layer, making it very easy. The technology was existing, but it became prominent with the advent of Amazon S3. A summary, if you look the cost, availability, durability, writes, and elasticity, you can see that an object store performs very well, especially Minio. I have looked at many object store open source implementations like Minio, OpenIO, Ceph, Cloudian, etc. But the most simple, very stable, and unbiased objective recommendation is Minio, because you can see how quickly you can get it up. Minio supports all these accesses. It can be deployed into Docker, Kubernetes, Drive, NAS, Azure, GCP, etc. No point in deploying into Amazon. Why? Because S3 is completely interoperable. So when you create a kind of object in Minio, you will be able to access it from Amazon, or you can access from Amazon and put it into Minio. They created the API in such a way that seamlessly both can coexist. Now, the fundamental unit in an object store, when you create, is not called as a folder and a file, but they are called as buckets. You create buckets. That's why if you read the S3 documentations and all, always they will be talking about S3 buckets. The data will always be put into bucket. And it is not like file system where a bucket can contain another bucket, bucket can contain another bucket, etc. A bucket will contain all your objects along with the metadata. Logically, metadata and data are separated. Let us look at the demo so that you will be understanding these all concepts very clearly. I will just pause for any questions before I let into demo so far whatever I have covered. Any questions? Your MapReduce can solve where splittability is there, where the MapReduce can yield results in a very fast way. Please continue to use that. I am talking about those class of problems when you are having large amount of data and you want to run your machine learning algorithms with the different tools. Today I want to run it with MXNet, tomorrow TensorFlow, third day Cafe, and then I want to use Torch. I need that file system to be plugged in and plugged out from different architectures. I should be able to take it, put it under a GPU or TPU. I can't do that if I rely on HDFS. So those class of problems where HDFS is good for, continue to use that. But when you are thinking about a data lake where large amount of data are going to be stored and you want less maintenance, you want elasticity, you want less cost, then you go for object store. All right, so let's start here. And let me know if you're having any questions. We'll start. Maybe we have to go through so many things, right? Hopefully. All right. The first step is going to be starting Hadoop. Why? I'm going to use some Spark programs, and I already mentioned to you that Spark uses Hadoop in the back. So some of the Hadoop files are needed, and we need the file system as well. So let's start Hadoop. And before starting Hadoop, I want to introduce to you Docker. Most of you might be using it. If not, please download. Fantastic use. Rather than a virtual machine, start using Docker. And how will a Docker look like? Very simple. If suppose you look at my directory, my Docker world, for example, you can see all these are Docker images. Nowadays, whenever I want to work with a Hadoop version or a Spark version, I don't need to download it on a virtual machine, and then I don't need to, remove the image, add the image, etc. Virtual machines use hypervisors, whereas Docker will be relying on your own operating system, and you can create whatever image that you want in seconds. You just need to pull it from the Docker Hub. So I got the Docker image of Minio, and you can just create it in a few seconds, the Minio Docker image. And some commands I am seeking the help.txt, which I have created for avoiding too much time typing the things. So I'm going to start the Docker image for Minio, and I'm going to start it. Okay. You will usually get this error if suppose the previous instance is not closed correctly. So I'm going to remove that Docker image, and then I'm going to execute that command one more time. Your object store is ready. It is going to tell you some messages, and that messages are very important, which is giving you another fundamental idea of object store. To access an object store, you will be needing I have to start one more server because I have integrated it for the demo purpose with Elasticsearch. So what I'm going to do, I'm going to go to my object store directory, and I'm going to Elasticsearch, and then I'm going to start Elasticsearch /Elasticsearch, and then let's come back here, and then let's execute the same command. let the Elasticsearch start. All right. That's how you will be getting it. Every object store will have an access key and a secret key. That's the key. If you are taking an Amazon S3 bucket, you are going to get the access key and access secret. There will be some more other data, but these are the most important things. The first thing that we need to do is, once the object store is started, I'm going to start Hadoop, and while I'm starting Hadoop, I will tell you what is internally happening. So I'll go here, and then I'm going to go to my lib directory where object store is there, and I'm going to go to the Hadoop 3.1, the latest version, and then we have the sbin, and then we are going to write the startall.sh. And while it is starting, let's open another window, and let us go to the directory where the Hadoop is installed, and let's go to the configuration of the Hadoop. Where is the configuration? It will be in the etc/Hadoop directory, and it is called vi core site.xml. And if you look at the site.xml, you will see how you will enable object store in Hadoop just by 4 or 5 lines. That access key and access secret that I got from Minio, the object store, I have put it inside my core site.xml, telling that my endpoint now is an object store, and please support S3 access. That's what I am saying by this. At the moment you are having it, and if your Hadoop is started, what is going to happen is you come here, and your Hadoop is started here, I think, right? And then I am going to start creating my things inside the object store. Now, to see the object store, they are giving you a browser, right? Automatically. The moment you start the object store, you can go to localhost, and the port is 9000 by default. And you can see that it will be asking you the access key and the access secret. So, what we can do is we can go to that same screen where you have started it. This is my access key. Copy it and then paste it here. And this is my access secret, which is this one. And let us go here and then paste it here and then click on this. You got the object store. And all these left hand side, what you see are called buckets. And if you look inside a bucket, you will see that I have got the data inside. The data can be files or the data can be objects. Ideally, it should be objects, but you can put anything. And it supports from few KBs to 5 terabytes. It uses eraser coding internally in order to manage the copies. And it is mounted as a disk. You can just plug it out and put it into TensorFlow, put it into any other TPU or GPU, and then start working. Right? So you got the object store there, and you got so many buckets. So let's take a bucket. My demo is a bucket, right? And what I'm going to do here is I'm going to write a command. Let me go to my directory, my Docker world, and then Minio, and then we are going to create a file. Okay, so I think there is a hello.txt. So my hello.txt is containing hello world. What I'm going to do, I'm going to put it into Hadoop. The object store. How will I do it? Hadoop fs minus put hello.txt. 2. This is the difference. S3A is the protocol that I'm going to use because I configured the endpoint in core site.xml. And the name of the bucket is my demo. And the name of the file that I'm going to put is hello.txt. You have to write that complete command here. If everything is okay, you should be getting the message, and you will see that now if I click on my demo, you got hello.txt, which means that you have successfully put it. All your Hadoop commands are now ready to be used against the object store. All your Spark programs, all your applications will work. The only change that you need is just to change it as S3//. Now, the important thing is that when you are writing this, it is creating S3 pointing to this Minio server. I can have another endpoint, S3 endpoint, which is pointing to Amazon, and I can have seamless joining or interoperability between that bucket and this bucket if you want. Amazon actually gives you a tool, and the tool name is S3 if you're familiar. So you can just download that S3 CMD, which is available open source, and you can execute the command /S3 CMD in order to put that into Minio as well. So see the interoperability. This is from Amazon. But since Minio supports S3, you can use that Amazon commands as well to put it into this one. Let me show you. I forgot the command. I will just look at the help, vi help.txt, and here you go. So I'm going to create a bucket. See, look at the command. It is not a mkdir, it is mb, make bucket. That's the command. So come out here and then go to the this directory, where is it, S3, this one, and then write the command, and then let us create it as Jax Big Data 1 as the name of this particular bucket, and then press enter. And let us go here and then do a refresh, right, of this particular screen, and you should be seeing JB1 now, because that shows you the interoperability between S3 and the Minio object store. Anything with S3, it will work here as well. Okay. Now, Hadoop command I have already shown. Now, how will you use Hive? That is very interesting.
It's not just an API; it's both a physical existence as well as an API.
Yeah. Yes. Absolutely correct. And now you come back here and let us go and do something on Hive. So before going on Hive, let me again check the help hive.txt, and what I'm going to do is I'm going to start the meta store of Hive. Okay, Control C, and then come here, and then I'm going to start the Hive server 2, which is starting the meta store. Anyway, if you want to work with Hive, you need to have the meta store, no doubt about it. And then what I'm going to do, I'm going to create a table, and I'm going to create it pointing to the S3 location. Look at the beauty. So I'm now creating a Hive table, but that Hive table's underlying data is in my S3 bucket. So I'm going to take that one, Control C, and then come here once the Hive is started, and put that particular data. And if you look at my bucket, I have got a table, I have got some data I already put in called myschools.csv. So what I'm going to do is that I'm going to use that particular table in order to create it, in order to create that table. Hopefully, I think there was some connection with the net. Okay, and then what I'm going to do, I'm going to open a new window, right, and then let us write the command Hive, right, and let's create a table now. Right, Control V, and I'm going to change the table away because I already tested this particular schools one, so I'm going to call this particular table as Jax Big Data schools. Okay. And let us do a select now. Your Hive underlying data is in the bucket, and select star from JB schools. You got the data. Your Hive is completely interoperable now, right? Having seen this, now let us look at a unified data architecture. Why? Because you put all the new data into object store, but you have your database existing. The best, the powerful, Presto. So what I'm going to do is that keep the Hive running there, but I don't want this Hive prompt, and I'm going to go to my object store, and I'm going to go to Presto. In Presto, there is an etc directory and a catalog directory where you are going to write now what is your Hive property. So in the Presto, there is server, sorry, I have to go to server, and then I have to go to vi etc /catalog /hive.properties. Look at that, what I have written there. I told Presto that when you are accessing Hive, you have to make sure that the underlying data is in S3, so please go to S3 and then fetch the data. And once you are doing this one, what I'm going to do is start Presto. So you will do that by going to the server again, and then you have got bin/launcher space run if everything is successful. And once it is running, and you get a message that server started, which means that everything is running well, and it will add all the properties, and you can see that now it is connecting, and the server is started, and you can come here now, and then I am going to now access my database as well as S3 in a join. So what I'm going to do is I'm going to go to cd lib cd object store and then cd presto, and inside the Presto you can see that there is a command line tool called Presto CLI. Java -jar Presto CLI executable.jar. It will show you the Presto prompt. It is ready for commands. And now let us write show tables from Hive.default. You have to give the database name as well as the system name, and you should get your JB schools also along with the other tables, which means that now Presto queried it through the S3. And now I want to show you, if I show catalogs, you can see that how many catalogs I have configured in Presto. I have configured Hive, Kafka, memory, MySQL, which means that I can now join everything together, out of which one is S3. How will you do that? If suppose you want to do that, you can write, for example, see, look at this, select star from MySQL dot movies dot ratings is a table inside my MySQL table which is running. If you want, you can see here by opening the MySQL workbench, and then you can connect to the root, and then you can see that there is a MySQL.policy, MySQL.movies, and movies, under the movies there is a table called ratings, right? And what I'm going to do is I'm going to come here and I'm going to do a select star from ratings. But remember, you are doing it from unified data architecture, not a simple SQL prompt. You got the data. Presto queried MySQL. Now select star from Hive dot, entirely a new system, Hive.default dot default dot the name of the table is JB schools, which is the table that we have created, and you should get the data which is coming from S3 Minio now. And if you want a query, if you want to join, okay, I don't have a join key, but I will just write the query. If you want to join it, this is how you will do it. You will get some data, but you understand what is the concept, because if you have a common column, you can easily write a particular join. It's a complex query. You can see that it will be joining the data between S3 and this. Now the CTO is very happy. CTO can do anything that he wants. Analytics is easy now. You can join anything that you want. And last but not least, what happens if suppose you are writing a Spark program, and how will you write a Spark program? Okay, so what I'm going to do now is leave all about this Presto, and I'm going to close this Presto CLI, and I think I can start the Presto this command prompt as well. So Control D. And what we are going to do now is we will go back to cd-lib/object store, cd my Docker world, and then cd minio, and then ls. Okay, and let me show you some a beautiful sample here. Okay, Spark meta sample partitions. Okay, so let us do one thing. What I'm going to do is I have got a meta sample code. And inside the meta sample, you can see that I have got a Java code, src com main and Java demo.java. Look at that. I am connecting to Minio client with the same keys that I mentioned earlier, and I am creating the cute brown fox jumps over the lazy dog as my string. And look at this. This is the extra feature that you have, along with the data, which is the cute brown fox jumps over a lazy dog. That's your data. I want to put metadata. And how will you put metadata along with the object's data? This is how you do it. You just put X Amazon object name. What is that? X Amazon meta custom data, some more data. You can put whatever data that you want as the metadata. Remember, that is not the data. And look at this syntax, x amz slash meta. And you add whatever you want. For example, if you want to add, let us say ID, then write dash ID. But this word should be common. That's Amazon standard. Now, do you know why I put that patient ID and patient ID previous scan in this particular day and so on and so forth? Look at the miracle that you can do with this particular architecture. Assume that whenever I am putting the data, I am putting this metadata also. So, whenever the patient is getting updated, I am going to put this metadata and I am going to link the current visit with the previous visit. The previous visit with the previous visit. With the previous visit with the previous visit. By this particular previous. I got a linked list of the complete transactions the patient has done. I can now use graph algorithms in order to traverse. I can create a private blockchain cloud, which is the chain of all the transactions, if I come up with a good proof of work. That is the power of object store. By keeping this metadata separate, you have the ability, and assume that this is a Spark program. And you are telling the metadata, telling that this is a Spark program copying data from DB2 to object store. That is your metadata. Now in the object store, assume that the data is coming from Spark, Scoop and Flume. And you are writing that metadata for Spark, Scoop and Flume. And you look at your data. Your data is full, but you don't know how much percentage came from Spark, how much percentage came from Scoop, how much percentage came from Flume. With this, you can. No lineage tool in the world currently is providing you that facility. The ability to know how much data got populated from which system. All profiling tools and data lineage tools will tell you how much percentage is good data. I don't want that. My object store is getting populated by many programs. Real-time streaming program, batch program, Scoop program, a Java program, a real-time Kafka is, event bus is updating it. I want to know which system updated what percentage of the data. How will you know that? This is the facility. Now, one big problem is there. This I used a Minio client. If suppose you are putting symbol files into your object store, it is not possible. It is not possible because file does not have these facilities. Only objects have. So it is a big challenge where I had to do some innovation. How can I write from a Spark program not a file but an object? Are you understanding what I mean? Because if you write a file, then there is no use. What is the use of using Minio, an object store, for putting a file? Let us put objects. But objects you can put only if you have this type of clients. The way in which you can handle that is, look at my CD, Spark meta sample partitions example. And I'm going to open the Scala code this time. So VI, source, main, and then Scala, and then meta update.scala. How will you do that? You are parallelizing the data and you are calling an update object store method. The update object store is the method in which you are putting the metadata along with your data. So what happens when you are writing this is Spark will be writing not a file but an object with metadata. In this way, you can track that object as well into your program. Normally, you don't put files into objects. So this architecture is the best, where you deal with an object store, you put only objects. Don't worry about files at all.
This is for really unstructured information.
Yeah, unstructured as well as structured. You can convert it into a structured information as well, if you want. Otherwise, you can just dump the files as it is.
But
Right.
it's already structured, you just query the file, right? It becomes something as an input to your Hive data. So if it's unstructured, then you could use that metadata. For sure.
Absolutely, you can use that metadata. And it is completely different from the normal metadata that you get when you are putting a file or so. You are customizing the metadata by yourself. Right? Now, last but not least, Minio comes with an integrated search capability. So what I'm going to do, if you look, I have these images, right? And you can see there is an image. So I'm going to delete this particular file, okay? So delete the selected file and I'm going to delete it. All right. So after deleting this object, what I'm going to do is, let me go back to the parent directory here. And where is it? Okay, there is a scaling1.jpg file. And let me just look at the help. I will open the help here. cd lib / object store and then cd minio vi help.txt cd minio cd my docker world cd minio and then vi help.txt and inside this, what I'm going to do, as you can see, let me run a command now to see whether I have attached any events with that particular bucket or not. So there is an images, as you can see on the extreme left, that is the bucket name. And what I'm going to do, so before coming here, I have just attached this one, the listener to that. And before that, let me start a Minio client. Okay, client is different from server, so I'm first starting a client. So this is how you will start a client. And after the client is started, what you are going to do is you are going to check whether there is any event attached or not. I should get an output, which means that the event is still active. Yes, the event is still active. And now you see the fun. I'm going to put an image, okay? And you see in my directory there is this scaling1.jpg that is available, okay? So I am going to do mcmb and then put this particular message. So images and then this is a command. It is file name is wrong, so I'm going to change this one as scaling, and I'm going to give a name as sample.jpg and press enter. Good, it has got updated, and now I'm going to query Elasticsearch and let's see what happens. Because the bucket is attached with an Elasticsearch listener, when you write this, oh, good, you will see that you have just uploaded a sample.jpg. All right, oh, got it, sorry, right? Sample. So Elasticsearch is integrated. Just imagine in a Hadoop file system, you are putting your unstructured data and you make it available into Solar or Elasticsearch, how much difficult task it is. Anything you put in, your content management system by default is ready. So that's in a short time that I can tell, explain you. Please work on this Minio. I will be sharing these particular slides in the meetup link. And as always, it is your enthusiasm and cooperation that is helping me also to come and present this kind of topics. And great thanks to Carly, Kyle, and you don't know, one more person is there, Katie. She's on vacation. She's not there here today. They are doing a tremendously great job by bringing in me kind of people and then allowing you to speak whether you like or not, right? That is a great thing.
Hardly anybody showed up.
And kindly please provide the feedback to Jack's Big Data site at the meetup if you don't mind. If you have taken pictures, please put it. And those people who have got a t-shirt, Minio had sent. I don't work for Minio. I'm not attached to Minio. Please don't think that I have got Minio. They just sent to me telling that you are doing some, without any relation, you are marketing for Minio, or you are working for Minio, or you are talking for Minio. That is great. And they sent some 20 or 25 t-shirts. That's what you got within the limited scope that's available. So please wear that and let's have a photo. We will send them back. Okay. And thank you very much for coming again.
we're gonna do something a little bit different
Are there
today.
any questions? Any
Professor Ravi,
questions for
Oh, sorry.
speaker?
Yeah, please. I'm
how
sorry.
do you compare Minio with Lustre FS or Ceph? The open
Yeah, so, it is a question like, Jyoti, how do you compare Oracle with the DB2, right? It is different open source products. Personally speaking, what I liked is the simplicity and the integrated capability of this particular tool while compared with other installations. I have almost done with all the four, Ceph, Minio, OpenIO and Cloudia. But this seems to be less error prone, very clear. But please remember that you lost data locality. So it is not suitable for Hadoop kind of MapReduce applications. Your application should be related with large amount of data, machine learning, right? Where time does not matter. That's the most important thing to know.
And what kind of high availability redundancy does Minio have?
Other than search?
No, like Minio, high availability. If you lose that thing, it goes down,
Oh
right?
no, yeah, you have got Docker Swarm. Similarly, you have seen that Kubernetes,
Also, you
right?
build
You have got OpenShift integration, Azure Cloud, you can implement it. So all kinds of standard fault tolerance mechanisms.
Yeah, but you have
are
to build
provided.
yourself. I mean, or put something.
Absolutely. Okay.
Same thing for ownership of files and groups and like that. You have to build your own stuff and talk.
There is a project going on which is going to be added to Minio very soon, which is allowing you the bucket level and the folder level security, full-fledged security. Yeah.
Okay. Any more questions?
How would this stack against EFS? This, you compare S3 to EDS,
Right.
storage. What about the EFS thing?
You mean the ext3
file system?
Yeah.
The Elastic File System.
Right.
The Amazon. How would this? I'm not very familiar. I don't know if you were very familiar with how
But
this would
I
stack
have
up.
not worked with the Elastic File System, but I think it is the basic is S3. Okay. By the way, in Amazon, S3, the cost that I mentioned there, $23 per terabyte. If you look at Amazon Glacier, which is a separate thing, the cost is still lower.
Right.
Right. So there are many options that are available. Right. But this is, as you have seen, it is just a terabyte of disk that you are going to attach, basically. Right. Lana?
I'm looking for render is not render. Oh, hello, the pop-up.
Okay.
Thank you so much.
Yeah.
No problem. Thank you.